So let's talk about the exact approach before we leave. So if your sample has finite possibilities, okay, so you can find the exact probability of each value coming out when you sample it. So let's say when you're tossing a coin, right, heads or tails, there's a 50% chance of each. You can come up with the exact probability. That will be a true sampling distribution. It's not even an ideal sampling distribution because you know the exact values, okay, that are possible. It's way better than an ideal sampling distribution. Let me give you an example of coins. Let's toss 3 coins, okay? Possible outcomes, heads or tails for each one of them. So let's say the first one we get heads, heads, heads. So, and now we're going to compute the number of tails we got. How many tails did we get this time? 0 tails, right? So we're going to compute once we got 0 tails, right? So heads, heads, heads. Okay, now let's do heads, heads, tails. Great, we got this outcome. How many tails do we have? 1 tail. Okay, how many tails do we have this time? 2 tails. 3 tails. Okay, great. Now, we toss it again. We get 1 tail face, face. Well, how many tails do we have? Well, we have 1 tail, right? So this is the number of tails, 1. And this is happening for the second time in our sample, right? So we're going to sort of truncate this with the previous set. We don't have to repeat it. It's not about the order, right, of coins. It's about the total number of tails. So just if you're confused, I'm just piling this up here because it's 1 tail. Okay, if we keep doing that, if we keep tossing this coin, we're going to find this distribution, which, by the way, looks like a bell shape. Wow, what a coincidence. Am I surprised? No. And if you turn that into fractions, you find that that's, 1/8 of a chance, 3/8 of a chance, 3/8 of a chance, because 8 is all the possible tosses that you could find when you toss 3 coins. And it's true, like there's no other possible toss you could find when you toss a coin. So this is an example of an exact approach. Coins, you can calculate the exact probability, but they're still respecting a normal distribution, which is insane. So just if you're confused, you can just stop and read this. I wrote down pretty much what each of them would look like. And this is the example they have in the book too. Let's also get used to probabilities, right? So we can do 12.5%, 37.5%, 37.5%, 12.5%, which is just, the fractions divided by each other. But we only use the exact approach for discrete data, okay? So integers and stuff like that. Categorical data, that will work. In continuous data, right, we have infinite possible outcomes, so we can't really calculate the exact possibility for each possible outcome. We can only make an inference with the curve. It's very abstract, I know, but we've discussed this in the Fisher's exact test in our chi-square class, so go refer to that one if you'd like. Gratitude breath. So this is it. See you next time.